Welcome back to Blockstream Talk. Today we're talking to Robin Linus and Lucas George of ZeroSync. ZeroSync is a nonprofit working on technology that allows for a compact cryptographic proof to substitute the hundreds of gigabytes of information that make up the Bitcoin blockchain, meaning the entire history of Bitcoin could be validated in an instant rather than in hours or days. It's pretty early days, but I think what they're working on leaves a lot of room for imagination. And when combined with something like the Blockstream satellite network, the implications are pretty far-reaching. All of a sudden, every smartphone on every part of the planet is capable of validating the Bitcoin network. And the number of nodes goes from something like just under 20,000 to maybe 20 billion or more. This was an interesting conversation, and I think we've only just scratched the surface of what this could mean for Bitcoin. And I think again highlights how early we are still, not only in the development of Bitcoin, but also in cryptography more generally. Don't forget to like, subscribe, and share. Lucas, Robin, thank you for joining us today.
Thanks for having us.
Yeah, hello.
Do you want to start off, kind of let us know what ZeroSync does? And then maybe kind of differentiate with what you guys do at ZeroSync and how you got involved with this.
We are using the zero knowledge proofs to basically compress the Bitcoin blockchain. That is, in one sentence, what we are doing. And we're using Stark proofs. And they're a particular kind of zero knowledge proofs. What's important about them is they are transparent, which means there is no trusted setup involved. That is a very important point in comparison to other zero-knowledge proof systems. For example, Zcash, they had been using the Groth 16 zero-knowledge proofs in the beginning, and they were criticized a lot for their trusted setup. Starks were invented later, and they just get rid of that entire trusted setup, which is a huge improvement. And also they are scalable, which means that for the first time they make it possible to have really large computation in a zero knowledge proof. For example, verifying the entire blockchain.
Yeah, and Lucas and Robin, maybe you can talk a little bit what your role is within ZeroSync.
I started the project. It originated from my bachelor thesis, so therefore I'm still involved. Like, I'm the longest around this project. I know all the ins and outs, and I still put in my effort. And Robin basically took the role of the project lead, bringing people together, creating the association, while still pushing the code to be a bit more production grade, not right there, but as you can imagine, it started out as my thesis and the code was not that polished, and I definitely learned a lot from Robin, and stick around right now for the project to turn it into a reality.
Great. And so the structure of the project is a nonprofit, right? Not a company.
Yes. We're a Swiss nonprofit.
And can we take a step back and maybe can you explain for the audience, what are zero knowledge proofs?
The funny answer is that most zero knowledge proofs are not zero knowledge proofs, which is kind of weird, because zero knowledge proofs have originally been invented for privacy reasons. And also, I think Blockstream is developing bullet proofs. I think some of them were also involved in inventing them, and they are also implementing them. And those are classical zero knowledge proofs, and they are used they are not used in Liquid yet, but they were invented, for example, for range proofs for confidential transactions. So a proof that my amount is not negative, for example. I send a transaction and I prove that the transaction value is not negative. I'm not creating value. I'm not creating money out of thin air. And this is a very classical application of zero knowledge proofs, which means I can prove and you gain zero knowledge from what I'm proving. And that was the original application. But then later people found out that those proofs are also very succinct. and that enables a form of compression. And nowadays, zero-knowledge proofs, or like that huge hype that is going on with also ZK rollups and stuff, that is mostly related to the compression ability of zero-knowledge proofs, which allows to take huge computation and compress it in a very succinct proof.
Got it. Anything to add on that, Lucas? Are you happy with that answer?
Maybe the most important thing, without losing any security. So it's a cryptographic measure to have a very large computation or a very large proof, be able to verify it succinctly without having to trust the prover.
That is an important part that surprises people often, that there's absolutely no trust involved. Even if your biggest enemy creates the proof, there is no way for them to cheat.
You mentioned compression and privacy. So how does using ZeroSync improve Bitcoin scalability and privacy?
The main application we are currently building is the chain proof, which is a proof of the entire blockchain, and it allows you to sync the chain state instantly. So instead of downloading the entire blockchain, 500 gigabytes or so, and verifying that entire 500 gigabytes, you just verify a proof, and that proof is as good as if you had downloaded the entire blockchain.
All right, so the implications of that sound massive. I mean, what are some of the implications that you guys are thinking about that?
A nice image is like everybody could run a full node on their phone.
And how does this technology differ to kind of other similar things being done on other protocols?
I think the major difference is on other protocols, we see these L2s, these rollups, and for Bitcoin, this is not as easily possible without a hard or soft fork. So we thought of an application that could introduce dark proofs to the Bitcoin community and the Bitcoin network without requiring a soft fork and a huge discussion about it, just to see if it would work or if the community is even interested in that. And then it turned out that the chain proof and syncing a node is like a very good first benchmark or first example to get people to know about zero knowledge proofs or get involved with them.
Great. You mentioned, that the future could be with this technology is that you could have, I guess billions of phones at this point. I think there might be more phones on the planet than there are people at this point. And every one of those phones could be a node for Bitcoin. That makes me think about the Blockstream satellite. And I think that has its limited bandwidth, right? And I think that syncing the blockchain obviously would probably take up a lot of that bandwidth. How does that integration work? I know that you guys have recently had an announcement on that.
Yeah, the Blockstream satellite and ZeroSync is a perfect match because the bandwidth constraints are so strong with the initial block download in particular. And currently, when you sync with Blockstream satellite, it takes, I think, more than a week or even weeks. And a ZeroSync proof would allow to sync that basically instantly. And that would be definitely a huge gain in comparison to the current system.
And what do you think are the implications of that? I guess it makes, even behind, so I'm in Taiwan, of course, right? So we have a neighbor offshore with a firewall. And I guess for places like that, it just makes Bitcoin so much more usable and resilient, right?
Also, you could build like sub networks, like one person receives it via satellite, and they can easily reshare the proof with all other people in the community, which is much easier with a proof than with a blockchain. Like, of course, you could also reshare the 500 gigabytes of blockchain.
Meaning that if you're in some kind of rural, maybe rural Africa or something like that, and that someone has access to Blockstream satellite, that they could kind of act as a hub and a spoke for everybody around them that could, that they could interact with on a mobile device. Is that kind of the idea?
Exactly that, yes. There is, of course, another layer, and we should first finish the first layer, and that is still a lot of work. But the grand vision would be that, people could reshare those proofs in rural areas and create like a subnetwork for Bitcoin.
What do you think the benefits of that to the average user are? If you're not kind of a technology power user, or maybe you're not even interested in running a node, what are the benefits of that to kind of the average user?
So I think aside from syncing a node, there are also a lot of applications for interoperability between blockchains. So now when you want to verify a payment that happened on the Bitcoin chain on Ethereum, there's no easy way to do so. You have to look into the blocks, and then you may lose security because you only look at maybe the last previous 100 blocks or so. Even that, I think, is a lot, but using a proof is like the foolproof way to do it. You still have the original security from the Bitcoin network. You have a proof that is very, very, very hard or impossible to forge, and you can look into the Bitcoin blockchain and just see if the payment happened or the transaction happened. That's like another way users would benefit, or the whole ecosystem would benefit from it.
And how close are you guys to deployment? Is this something that you guys are working on already? Is it deployed? Are people using it in the wild?
This is still a very early stage, and we have just completed our first major milestone of recursive chain proof. That means we have implemented most of Bitcoin's consensus rules, and we have also implemented a recursive verifier that is necessary to incrementally extend proofs. That is because like you have the current blockchain, we prove the current blockchain, and now a new block arrives. And now we don't want to reprove the entire blockchain. We just want to prove the next block and extend the previous proof with a proof for the next block. And this works by verifying that the previous block was correct. Like verify inside of a proof, we verify that the previous proof was correct and add a proof for the next block. And this way we can incrementally grow the chain proof over time. And therefore this recursion was very important. And now we have built a basic implementation of both of that, but that is still prototype level. It's not production grade cryptography. And we'll still have to make it much faster. We have to improve the performance of the prover in particular.
And what is the timeline? How far away do you think production is?
We want to roll it out in multiple stages. The first stage would be just a headers chain proof. That is not that interesting by itself, I'd say, but it's it makes sense to have it as a first milestone. And hopefully we can roll it out by the end of this year.
Oh, that's great. That's amazing. And what are the kind of the hardware requirements for running ZeroSync enabled nodes?
So as a verifier, the hardware requirements are very low. So we have a demo that can verify the proof inside your browser and even on your phone, basically any machine. And on the other side, though, the prover hardware has to be beefy, to say. At this point, it requires a lot of RAM. So we're talking a couple of 100 gigabytes up to a terabyte of RAM, and also a lot of time. Definitely at the current stage, still more than the 10 minutes that are the timeline after every new block is created on the Bitcoin network, which kind of right now is a problem, but we have some solutions for that. We can parallelize proof generation, and there's still a lot of way to optimize different parts of the proof generation. And yeah, but this huge discrepancy is kind of good for the consumer, but very bad for the person that wants to generate proofs.
What kind of documentation do you have available for anyone who wants to set up and use ZeroSync and maybe even incorporate it with the satellite?
Not yet that much. Like also the satellite project is also very much in the early stage. We have not published anything yet. We got in touch with Adam Back and we told him about it, and then we figured out that it would be a great match, and then we started to team up on it. But there is nothing production ready yet.
What are some potential use cases for the ZeroSync toolkit, and how will it enable developers to create more sophisticated on-chain applications?
My example was always wrapped tokens, for example, on other chains, on Ethereum, wrapped Bitcoin, without any loss of security. And I think Robin has some more applications as well.
One application that will work pretty certainly is to compress the transaction history of second layer protocols like Taro or RGB. I'm not sure if you heard of them, but they allow basically tokens on top of Bitcoin. It's like token and smart contract protocols on top of Bitcoin. And yeah, the main issue is that the transaction history grows quasi-exponentially, which means if you send someone a token, you basically have to send them the entire blockchain as well. And using zero-knowledge proofs, you could compress that in a very nice succinct proof, and then basically the proof becomes the coin. And yeah, that is a nice application. But also there are many applications for other fields. For example, the Lightning Network would be a nice field for application. I have not figured out the details yet, but I talked to a couple of people and we discussed if it is possible to increase the privacy of the peer-to-peer gossip protocol. Because currently you're kind of doxing yourself when you have to announce your own channels. And with private channels, you cannot do any routing. And it might be possible to use zero-knowledge proofs to do routing with private channels, basically.
Is that work that you guys are doing as well, or is that something that other people are working on?
The toolkit is basically a byproduct of what we are building, because we are implementing all the Bitcoin consensus rules. So it's basically a byproduct that we are creating a library for Bitcoin proofs. Like you can reuse our proofs to prove anything about a Bitcoin transaction. And yeah, when we figured that out, we decided that we're gonna ship that toolkit as well for people to customize proofs and to customize them for their individual use cases.
And what about Starks? How does this relate to simplicity, and how can this cross over with the Liquid sidechain?
The big dream is definitely to have some ZKP verifier on the Bitcoin mainnet, because that would enable all kinds of interesting stuff like rollups, trustless two-way pegs, and great scalability and great privacy, basically. And of course, it's hard to do any kind of fork with Bitcoin. And it would probably be impossible to convince people to activate a particular verifier because there are so many different verifiers and there are so many trade-offs to be made that it will be probably hard to find a consensus amongst the community to activate a particular verifier. But Blockstream came up with that beautiful language, simplicity. And simplicity is like the famous last fork. That is like a high-level programming language. And if that would get enabled, it would be possible to implement a Stark verifier in simplicity. And you wouldn't have to ask anyone about implementing that. That would be just be enabled by simplicity itself. And we don't know when simplicity will come to Bitcoin, but simplicity will be activated on the Liquid sidechain soon. And that will be great for us as a testing field and to implement a first verifier in a Bitcoin setting.
What are some of the other obstacles and challenges you guys have run into?
I mean, there were a lot of challenges and obstacles. First obstacle was there was no open source prover really. So we talked to a guy, Max, who was working on one and got it done to at least a certain point that we can use it for prototyping the ZeroSync application. Then there was no, or at least no open source recursive verifier for the language we use, and we had to implement it ourselves as well. Then, of course, the whole Bitcoin logic, what Robin was talking about, was not there. Like we are talking, there were no completed implementations for the basic hash functions used in the Bitcoin protocol. So we had to start really low level, do it all ourselves, or in combination with other teams doing similar things, or we had to go to create libraries for this. And therefore, as Robin mentions, we ended up with this byproduct, which is a whole toolkit to do like any Bitcoin related stuff in the language we use to enable other developers to create their own applications or things they wanted to prove.
Great. And what do you think are some of the big obstacles that remain for you guys to overcome in the future?
There is that huge asymmetry between the prover and the verifier. The prover is much slower than a regular full node, and the verifier is much, like a million times faster than a regular full node. but computing the proof once is very computationally intensive. And I would say in the current version that we have now, it's maybe even injectable. But there are lots of ways to improve the performance of the prover. And the main obstacle is to make proving fast enough to for us to be able to prove a full block within 10 minutes, because we should be able to complete the proof before the next block arrives, right?
Yeah, that seems essential.
Yeah, and maybe also do so in a costly manner. So of course you could just throw money at it, basically, and it's just a matter of how much. And we would love to bring this down a bit and not have to run hundreds of servers just to prove the Bitcoin chain in a timely manner.
How do you guys plan to ensure that ZeroSync's proof systems remain secure and resistant to any potential attacks?
Yeah, I think this is one of the main reasons why we turned this into a non-profit open source. So I believe we cannot do this like alone on our own, just have 4 or 5 people look at it and be like, it's fine. This is like the wrong approach in my eyes, and I have a lot of trust in the Bitcoin community, other devs, everyone involved with it, to have a look at it and eventually grind out every security issue and mistake in there. And the other thing is we can roll it out as kind of with a backup mechanism. So you could use the proof to instantly sync your node, and then over time use the old conventional way, so using the peer-to-peer network to sync your node. And if you find any errors after that, or if you don't find any, you can be sure that the proof was correct. So you cannot be fooled for longer than 3 or 4 days, which is still bad, but at least there is like this safety net that we can build upon.
The initial security requirements are lower than when you're doing something on the main layer. Like, for example, if we would introduce another signing mechanism or something, it should be absolutely completely hardened before it gets activated on Bitcoin, because once it's activated, you cannot change it anymore. And since what we are doing is all off-chain, we have the luxury of going slow, that we can first apply it to lower value use cases and like get it into the field slower and step by step, and kind of increase the pressure over time. As Lucas mentioned, there's also ways to combine it, like to have the instant sync with the proof and then a classical sync as a backup, basically. One option for that would be the new assume UTXO mode of Bitcoin Core, which basically allows you to tell your node, hey, here's a UTXO set, just trust me, that is correct. And then you can instantly start verifying new blocks. And in the background, your node starts syncing the entire chain and ensures that that UTXO set was actually correct. And this is a nice match with ZeroSync, because that UTXO set could be proven on the first instance, and it could be instantly proven. And even if we had made a mistake, that would be found because your node still does the conventional sync in the background, which will take a while, but at least at some point you would know.
For other developers that are interested in incorporating ZeroSync's proof systems into their projects, what advice would you guys have?
Yeah, definitely get in touch with us, because it's all very early stage, and I think we can help people a lot to find out the nitty gritty, and to see if it actually makes sense to apply to their use case. And we have a Telegram channel. We are very approachable, I think, and we are happy to help people get started.
And going back to the Blockstream satellite, can you guys think of any long-term implications for the future of the Bitcoin main layer network and for users?
I think eventually just more nodes, because it's easier to set up a node, even on smaller machines. You don't have to run even a Raspberry Pi. You could just have your phone, sync it instantly, and then even if you don't want to sync it anymore, or you feel like you're using too much bandwidth, keeping up with the network, you could stop being in sync, and then after a few blocks or a few hundred blocks, you turn on the proof again, get a new proof, and be up to date instantly. So I think this really lowers the entry barrier for users of the Bitcoin network.
Yeah, that's amazing, and just expands the number of nodes really by just a huge amount, right? Like it's really could have billions of nodes and
Yes.
with better geographical dispersion as well.
Exactly that. The security of any decentralized currency stems from everybody verifying everything. And of course, that scales poorly because your phone will not verify the transactions of billions of people. But with such a proof system, it is suddenly possible. And that solves one of the fundamental scalability problems of Bitcoin.
That's amazing. It's kind of interesting to think that Bitcoin has been around already for more than a decade, and it seems like we're still in a lot of ways in the very, very early stages of it, aren't we?
I think cryptography is in its early stages in some sense because of the entire crypto hype, billions and billions have been invested in cryptography research, and that's why we see all this magic constructions recently.
That's interesting. I mean, it couldn't have come at a better time too, right? Because at the same time that we're getting this push in cryptography and Bitcoin and decentralized money as being, better known more broadly than it ever has before, it seems like there's a lot of forces on the other side too, pushing towards increased centralization.
Definitely. Yeah, absolutely.
So I think that Bitcoin and what you guys are doing are probably, reasons for optimism when you look into the future.
Yeah, happy to hear that.
So is there anything else you guys would like to highlight before we wrap it up?
I think one topic that we haven't touched yet is that proofs or our chain proof allows to augment the chain with additional data structures. One example is that we have already implemented U3XO. So you have a UTXO commitment in our chain or in our chain proof. And that is pretty exciting because people have been talking about UTXO commitments for at least a decade, I think. And it has always been like there are many trade-offs, there are many different possible UTXO commitments, and people never came to a real conclusion. And also, when you just add them to the main layer, they might offer a false sense of security because even if you get the headers chain and a proof of inclusion for a particular UTXO, that doesn't mean that much. It's when you don't verify the chain, then you can still get fooled. But with such a proof, you cannot get fooled anymore. And that allows to index the blockchain in a very succinct way, or in a way that is very nice for light clients. So you don't even have to download the entire UTXO set. You can just make a query and ask, hey, what is my balance? And then somebody can give you the response, but they can never fool you. It's always proven that the response is actually correct.
So it sounds like there's just like numerous applications in terms of, compression, scalability, and privacy.
I think this is just the starting point, really. Like we were thinking of the first basic application we could develop to showcase dark proofs on Bitcoin. And there are numerous other things we can not even think of right now, I think. And it will be very interesting in the future to see what people come up with and how to use our toolkit, other toolkits to use dark proofs for Bitcoin. And I see a lot of potential there.
Yeah, basically everybody we talk to, they have new ideas how to apply it.
That's amazing. Yeah, I mean, who knows where this stuff is going to go in another 5 or 10 years? That's really exciting. If people want to support your work or learn more about what you guys are doing, where should they go? Just
go to our website, which is zerosync.org. And we are a nonprofit. We are also in the process of raising a sponsorship for our next milestone. And yeah, if you want to support us, please reach out.
Oh, great. That's great. Well, maybe we can have you guys back on at the end of year when you're ready for production.
That would be great. Yeah.
Yeah, it would be amazing.
Sounds great. All right. Thanks a lot, guys. Appreciate the time today.
Thanks for having us.
Thank you.